we have signs of very great changes occurring on the planet.
Everything happens so fast.
There's creeks dried up that have never dried up in my lifetime.
We've got a forest here that's already at the edge.
We're going into uncharted territory.
Our planet is at a crossroads. Global warming isn't out of control, but it soon could be. The warning signs are all around us. This is the challenge of climate change. What can we do about global warming? What will happen to the Earth if we don't? The temperature is rising. Each degree is critical.
Just 1 degree or so of
1 degree warmer than they should. Bump it up 2 degrees.
3 degrees.
Threshold is about 3 degrees of global warming.
3 to 4 degrees of warming.
You're starting to look at 4 degrees.
3 degrees, 4 degrees, 5 degrees.
6 degrees is almost unimaginable.
Imagine the 21st century if global warming accelerates. Where does the next superstorm hit? The next scorching heat wave? The next catastrophe? As the world warms degree by degree, the debate has ended. Scientists around the globe agree we now live in a world warmer by almost 1 full degree Celsius. Tracking the Earth's vital signs is an armada. Thousands of ships at sea, tens of thousands of stations on land, satellites monitoring from space. Scientists feed the data into the most advanced computer models. The predictions are alarming. In 4 decades, glaciers in the Himalayas, the source of water for millions, could be gone. Within 50 years, Greenland's melting ice sheet could be unstoppable. By the end of this century, the Amazon rainforest, home to half the world's biodiversity, could wither to an arid savanna. A temperature rise between 1 and 6 degrees Celsius is possible over the next century. Each degree means a radically different future.
Global warming doesn't just mean the slow increase in average temperatures. It completely changes the way the Earth system operates, which is why we can see droughts in one place, floods in another, or even a succession of drought and flood in the same exact location.
National Geographic author Mark Linus spent years compiling data from climate models to understand how each degree of warming could threaten the planet.
It's very difficult for people to visualize the future impacts of global warming, and it's something that I really wanted to try and do to help people visualize the reality, because it isn't actually intuitive that the emissions from your car exhaust are going to be melting a glacier in the Himalayas in 50 years' time.
While experts estimate the average temperature could rise up to 6 degrees Celsius, or nearly 11 degrees Fahrenheit over the next 100 years, the future isn't set in stone. Even a small shift in the Earth's temperature, just 6 degrees, can have extreme consequences.
Well, 6 degrees shift from one day to the next is the sort of thing that we expect with normal weather fluctuations. If it's 6 degrees hotter tomorrow, I might just be wearing some shorts. 6 degrees in terms of a global average change, 6 degrees colder is the difference between now and the last ice age, 18,000 years ago, when the ice sheets themselves advanced to just the edge of Oxford, and in places the ice cap was more than a mile thick.
Just 6 degrees of cooling transformed the Earth into an ice age. Imagine it 6 degrees hotter. The very earliest changes would start high above the Earth. The atmosphere is our buffer zone between the planet's surface and outer space. A small percentage are the greenhouse gases, a cocktail of water vapor, carbon dioxide, methane, nitrous oxide, and ozone. They are like a dome over the planet, retaining just enough of the sun's reflected energy to maintain temperatures that support life. As the amounts of those gases increase, they trap more heat and can radically affect the climate all over the planet. For the last 250 years, greenhouse emissions have soared as we find more and more ways to use more and more energy. CO2 is the hidden price we pay. Carbon dioxide rises into the atmosphere from the energy that powers all our modern conveniences. It's literally in the air we breathe. There are now 383 carbon dioxide molecules out of every million. It seems minuscule, but as the amount of CO2 rises, so does the average temperature all over the planet.
Doubling of CO2 is a guarantee for a global disaster. The dangerous level is about 450 parts per million, and we're already up to 383. Additional global warming of 1 or 2 degrees Celsius is a very big deal.
All we're doing is saying what we think our best estimate is what will happen if we carry on the route we're going. So all you can do is to lay out a number of possible pictures of the future and hope people will select the right one.
If the world warms by 1 degree, the Arctic is ice-free for half the year, opening the legendary Northwest Passage for ships. Tens of thousands of homes around the Bay of Bengal are flooding. Hurricanes begin hitting the South Atlantic. Severe droughts in the western U.S. cause shortages in global grain and meat markets. This could be our world plus 1 degree. Warming of just 1 degree could turn some of America's most fertile ranchland into desert again. 6,000 years ago, much of the American West was part of a vast desert dominating the continent. A minor shift in the Earth's orbit caused the summer sun to warm slightly, just enough to radically transform this entire region. Only a very thin layer of topsoil covers the desert sand that still lurks just centimeters below the surface. As we race toward a planet warmer by 1 degree, the global warming scorecard lists both losers and winners. While the western U.S. is dry and thirsty, England is enjoying an agricultural makeover. Fortunes will be made and lost if global weather patterns rearrange where different crops can be grown.
The winters, which used to be very hard in this country, are getting much, much milder, and so in some senses that's a good thing. That's of course not counterbalanced by the devastation which is affecting other parts of the world.
Right now, England is in the right place at the right time for one of the world's most fragile and most valuable crops.
You can't have it too hot for grapes. Of course, you realize in the Champagne regions now it's becoming too hot.
When David Middleton first planted Champagne-style grapes, neighbors thought he'd gone mad. But as wine-producing regions in France are getting hotter, the climate for growing grapes is migrating across the English Channel. The idea of a fine English wine is no longer a joke. Now there are more than 400 vineyards in Britain. The Earth's average temperature has always fluctuated, and a variable climate isn't unusual. It's the pace of climate change today that's unprecedented. The planet has experienced climate change before, but it usually plays out over thousands or millions of years. Now global warming is measured in decades, even years. It means scores of species won't be able to keep up. Warming at this speed could send us into uncharted territory, like nothing we've experienced in the history of life on Earth. Global warming started with our insatiable appetite for energy. Every switch we flip, every plug, every button we push to turn something on inevitably leads back to a place like this. Nearly 90% of the world's energy starts as a fossil fuel. Coal, oil, natural gas. These three fuels combined are the single largest source of CO2 emissions pouring into the atmosphere. If the world warms by 2 degrees, some changes to the biosphere are no longer gradual. Greenland's glaciers are disappearing. So much ice has melted, polar bears struggle to survive. Insects migrate in strange new directions. As a temperate climate moves north in the U.S., pine beetles kill off the white bark forests, a grizzly bear's key source of food in the fall. New forests take root in Canada's melting tundra. The Pacific islands of Tuvalu are lost beneath the rising tides of global warming. This could be our world plus 2 degrees.
At 2 degrees of warming, the impacts in the marine ecosystem are going to be much more severe.
The oceans are the planet's largest carbon sink, nature's primary mechanism for absorbing CO2 out of the atmosphere. But lately, there are indications these systems are breaking down. Under normal conditions, tiny sea creatures like forams and coccolithophores absorb carbon out of the water and use it to build their shells and skeletons. But there is a tipping point when too much CO2 in the oceans turns the water increasingly acidic. Acidification dissolves the creature's shells and skeletons and prevents them from absorbing more CO2 out of the water to build new ones. Some of these tiny animals at the bottom of the food chain measure only 1 millimeter. But the fate of all sea creatures, of all shapes and sizes, larger and larger, hangs in the balance. Alter the ocean's chemistry, and nature's primary mechanism for controlling the climate begins to break down.
You lose a coral reef, you lose perhaps 500,000 species. You lose those little coccolithophores, these little algae, and you start to lose things that are very important to life on this planet. We're losing some of the most vital elements of the way the world works, and that's got us all concerned.
Scientists half a world away share those concerns. They're investigating global warming at the climate's opposite extreme. It took nature 150,000 years to make the Great Greenland Ice Sheet that's now melting into the sea faster than at any time in history.